So today we are continuing with area, but before I do that, I just wanted to go back and review a few things with you guys. This is actually from the last unit, our trig unit. If you would like to, you could pause this video and go ahead and try these two review problems. I'm going to go ahead and do them with you now. So if you look at this first example on the left, this is a 30, 60, 90 triangle. Remember, this is a special right triangle, and there were a few formulas for 30, 60, 90s. If you want to use those to solve, you can, but I think most of you are more comfortable with using sine, cosine, and tangent. So I'm going to go ahead and use that to solve these two problems. So remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So SOHCAHTOA. On this first example, we have the 60 degrees down there in the bottom right. The side with the x is opposite of that angle, and the 3 is adjacent to the angle. So we have opposite and adjacent, so we are going to use tangent. So the tangent of our angle, which is 60 degrees, is equal to x over 3, opposite over adjacent. And to get rid of that 3 on the bottom, we're just going to multiply by 3 on both sides. So now x equals 3 times the tangent of 60 degrees, which gives us approximately 5.2. This is just to refresh your guys' memory because we will be using some of this today. And I'll do one more as well. So on this example, the 8 is the hypotenuse, and I know that because it's across from the right angle, and x is adjacent to our angle of 30 degrees. Since we are dealing with the adjacent side and the hypotenuse, we would use cosine. So the cosine of 30 degrees equals adjacent, so x, over the hypotenuse, 8. And again, anytime you want to get rid of something on the bottom or the denominator, you multiply by that number. So 8 times the cosine of 30 degrees equals x. That is going to give us approximately 6.9. So hopefully this is all super familiar to you guys. It is from the last unit, and like I said, we will be using it just a little bit when we are finding areas today. So the first theorem, Theorem 1014, is the area of a trapezoid. Now remember, a trapezoid is just a quadrilateral with exactly one pair of parallel sides. And the area of a trapezoid is 1/2 times the height times the sum of the bases. Remember, our bases are where our parallel lines are. So in the picture, we have base 1 and base 2. And notice those are the parallel lines. So we are going to find the area of this trapezoid in this first example. So we have the two bases, which are 15 and 17, and we have the height, which is 18. So all we need to do here is plug this into our formula. So the area is 1/2 times the height, which is in this case is 18, times base 1 plus base 2. And then we just solve. So this gives us a 1/2 times 18 times 42, which ends up being 378 inches squared. Remember, since we are talking about area, it is inches squared, not just inches. On this next example, we are also finding the area. So I'm going to write the area formula up here again. So 1/2 times the height times the sum of the bases, base 1 plus base 2. Notice we have this base right here, which is 6 feet. Since this bottom figure is a rectangle, I also know that this length is 6 feet. But I want the whole base, which is this length right here, the other base of my trapezoid. And this length is 3 plus 6, or 9 feet. So I have my two bases. What I do not have is the height of my figure. I am missing that side in green. If you look at this triangle right here, this right triangle, notice we have the hypotenuse and one other side length. So we could use that triangle to find x. Remember, if you have two side lengths of a right triangle and you are trying to find the third, we can use a squared plus b squared equals c squared, the Pythagorean theorem. So in this case, our c would be 5 because it is the hypotenuse. So that means our a and our b would be x and 3. So this would give us an x squared plus 3 squared equals 5 squared. 3 squared is 9. 5 squared is 25. Then we would subtract the 9. So x squared equals 16. And then finally take the square root of both sides. And the square root of 16 is 4. So now we know that the x is 4. So that is our height. So we found that this length right here was 4. So now we have everything we need to find the area of this trapezoid. So our area equals 1/2 times the height, which we found was 4, times base 1, we'll call that 6, plus base 2. And remember, the whole base on that right side was 9 feet. So 6 plus 9. And 6 plus 9 is 15. 1/2 times 2, or 1/2 times 4, sorry, is 2. Times 15 is 30. So our area is 30 feet squared. Next one. Again, I'm going to write the area up at the top so we can take a look at what we are missing. Notice we have both of our bases, 5 and 7. What we do not have is our height. So that is what we need to find first. We need to find this length. I'm going to call that x. Or let's call it h. H for height. Now, it looks like we have a right triangle over here. But we need one of the side lengths. So if this whole length is 7, and this length is 5. We can find this length right here. Oops. By taking 7 minus 5, which is 2. So that bottom or the shorter leg of our right triangle is 2, and we are trying to find h. So again, you can use the special right triangles formulas if you know how to use them, the 30, 60, 90 triangles. I'm going to go ahead and use SOHCAHTOA. So since we have the opposite side and the adjacent side, we are going to use tangent. We'll go ahead and write SOHCAHTOA up here as well. So the tangent of 60 degrees, remember tangent is opposite over adjacent, so our opposite side is h, and our adjacent side is 2. And to solve for h, all you have to do is multiply both sides by 2. So 2 times the tangent of 60 equals h. And that gives us approximately 3.5. So we now know that our height is about 3.5. So now we can use this to find our area. So area equals 1/2 times the height, which we found was 3.5, times sum of the bases, so 5 plus 7. And this gives us 21 meters squared. Now we are going to move on to area of a rhombus or a kite. So this is actually one formula fits all. This formula works for a rhombus or a kite. Now remember, a rhombus is a quadrilateral or a parallelogram with 4 congruent sides, and a kite is a quadrilateral with 2 sets of congruent adjacent sides. So there are pictures of both a rhombus and a kite there. And it says the area of a rhombus or a kite is half the product of the lengths of the diagonals. Remember, product means multiply. So we're multiplying the diagonals and dividing it by 2. So area equals 1/2 times d1 times d2, where the d1 and d2 are just the diagonals of our shape. So let's put this to use. So here we have a kite, and we want to find the area. I'm going to call this diagonal right here, long diagonal, the main diagonal, D1, diagonal 1, and that means this one can be diagonal 2. Well, I know the length of diagonal 1 is 2.
Testing, 1, 2, 3. Testing, 1, 2, 3. Testing, 1, 2, 3.
Sorry, guys. So the length of diagonal 1 is 2 plus 5, which is 7. And the length of diagonal 2 is 3 plus 3, so 6. Since I know the length of the diagonals, I can find the area. So the area is 1/2 times d1 times d2. So 1/2 times 7 times 6, which is 21 meters squared. So now we have a rhombus. Now remember, the diagonals of a rhombus, we know several things about them. We know that they are perpendicular. We also know they bisect each other. So if this segment right here is 3. That means this segment is 3. And if, oops, this segment right here is 5, that means this segment is 5. So I'll call the vertical diagonal, diagonal 1. And that one is 3 plus 3, so 6. We'll call this diagonal, diagonal 2. And that one is 5 plus 5, so 10. So the area equals 1/2 times 6 times 10, which is 30 feet squared. This one is a little more interesting. So we have this length right here. And since this is a rhombus and the diagonals bisect each other, I know that this length right here has to be 8 inches as well. Now, we need the length of the other diagonal, or the vertical diagonal. So to do that, I need to find this value and look at this right triangle right here. And I know that this is a right triangle because if we have a rhombus, the diagonals are perpendicular, meaning they meet at a 90-degree angle. So since we have an angle over here which is 30 degrees, and we have one of the sides, we can find x using SOHCAHTOA. And again, on this one, we will end up using tangent because we have opposite and adjacent. So the tangent of 30 degrees equals the opposite side, just x, over the adjacent side, which is 8. And then we solve. So x is equal to 8 times the tangent of 30 degrees. And that gives us approximately 4.6. So I know this segment is 4.6. And since the diagonals bisect each other, this segment is also 4.6. So now we have the lengths of our diagonals. I know that this length is 4.6 plus 4.6, which is 9.2. And this diagonal, the one horizontal, is 8 plus 8, or 16. So there's our two diagonals. Therefore, we can find the area. So the area is equal to 1/2 times d1 times d2, which is 1/2 times 9.2 times 16, which is about 73.6 inches squared. There's our area. And I have one last example for you guys today. So we have a rhombus, and to find the area of this rhombus, we need both of the diagonals. But we are only given one of the diagonals. That's not a problem. All I'm going to do is draw that other diagonal. So here's the other diagonal. Problem solved. Now, when I drew that diagonal, remember diagonals bisect each other. So this segment is now 3 meters and this segment is 3 meters. But I need to find this length. So I can use this triangle right here. Oops. I'll call this x. So remember, if we are given two side lengths of a right triangle, then we can find the third side length by using the Pythagorean theorem. And in this case, the 5 is going to be our c value. So our a and our b are just going to be x and 3. So x squared plus 3 squared equals 5 squared. 3 squared is 9, and 5 squared is 25. Subtract the 9 from both sides, so x squared is now equal to 16, and take the square root. So x is 4. So if this segment is 4, that means this segment is 4. So now we have our diagonals. Diagonal 1 is 3 plus 3, which is 6. And diagonal 2 is 4 plus 4, which is 8. So to find the area, we'll take 1/2 times diagonal 1 times diagonal 2. 6 times 8 is 48. Times 1/2 is 24. So 24 meters squared. That's all I have for you guys today.